All right, this is our extension video for chapter 10. Just a reminder that you only need to be watching this video if you've already completed all of the other homework assignments, all of the other quizzes, and you want a little bit of a challenge, or you want to learn something more about this topic that we've been doing in this chapter involving area. This video shows you some ways we can apply some of the things that we've already learned. All right, so what is probability? Well, you may have talked about probability in some of your past math classes, or maybe not. But all probability is a number that describes the likelihood that an event will occur. So 0 would represent that event being impossible to occur, can never happen, whereas 1 is that event is certain to happen. 0.5 would be the event is equally likely to occur and not to occur, and then everything else is just kind of a sliding scale between not very likely and incredibly likely. And you may be familiar with probabilities being expressed as a percent. We just would multiply the probability by 100 to write it as a percent. And how do you calculate probability? You might want to know. Well, what we're going to do is we are going to count up all of the possible outcomes. And once we do that, we are going to count up all of the outcomes that we're interested in, and we're going to divide those two numbers. So the number of outcomes where the event occurs divided by the number of possible outcomes. Let's see an example of this. Okay, we toss a coin 2 times. What's the probability that both times we get tails? So we want to think about what are all of the possibilities. Well, we flip the coin and we get heads, and then we flip the coin and we get heads again. We get a heads and then a tails. We get a tails and then a heads. Or lastly, we get a tails and then a tails. So in this case, there's 4 equally likely outcomes, 1, 2, 3, 4, and one of them results in both being tails. So our probability is 1 out of 4, which we could write as a decimal, which would be 0.25. We just do 1 divided by 4 to get that 0.25, and we could multiply that by 100 and get 25%. So for probability, you can express it any of these ways, as a fraction, as a decimal, or as a percent. Let's look at another example. Okay, we roll 2 6-sided dice. What's the probability that they add up to 5? Again, we want to write out all of the possible outcomes. Well, in this case, there's going to be a lot of them. So don't feel like you need to write down all of these, but you can just look at this. We have 36 possible outcomes. The reason for that is that each die has 6 sides. If we do 6 times 6, that's 36. And you can see all these outcomes here. Everything from a 1 and a 1 up to a 6 and a 6. So 36 possible outcomes. How many of them involve the dice adding up to 5? Well, we got 1, 2, 3, 4. 4 out of 36. So that fraction reduces down to 1 over 9. And yes, we always want to reduce our fractions whenever we can. So we would want to write our answer as 1 over 9, or as a decimal, if we do 1 divided by 9, we get 0.1 repeating, which as a percent would be 11.1 repeating percent. All right, you might think, what does this have to do with geometry? Well, we can talk about probability in terms of area. So if we have a region and we are choosing a random point on that region, we can calculate the probability that a point is in a certain part of that region. And we calculate that probability the same way of the problems we just did. We think about what are our outcomes where we get the point on the region we're interested in, divided by the outcomes where we are on the region in general. So if we want to know what's the probability that a point is in region A, we would just find the area of that region and divide by the area of the whole region. So let's see a couple of examples. Here we've got a square, and we're choosing a random point on that square. If we do that, what's the probability that the point ends up in the circle? Well, we need to calculate the area of the whole region and then of the circle. So first of the square, that is just going to be 20 times 20, or 400. Then for the circle, we have a circle with a diameter of 8. That means it has a radius of 4. So to calculate the area of that shaded region, we're going to do pi r squared. So pi times 4 squared, which gives us 16 pi. So to calculate the probability, we need to do the area of the shaded region divided by the area of the entire region. So 16 pi divided by 400. If we do that, we get approximately 12.5%. All right, one more example. Here we want to find the probability that our point ends up in this shaded ring if the point is in the circle in general. And now I'm noticing right here, I have a typo. We should say a point on the circle is chosen at random. So change that to circle. What's the probability that it is part of the shaded region in general? Okay, so the first thing we need to do is find the area of the entire region. In this case, the big circle that has a diameter of 16 inches. Well, we're going to have to do pi r squared, radius being 8. So we get an area of the big circle of 64 pi. Now we want to find the area of the shaded region, the ring. But to find the area of the ring, what we actually need to do is take the area of this whole circle and subtract off the smaller circle. So first we actually need to find the smaller circle. Well, that's a circle with a diameter of 10 or a radius of 5. So that gives us pi times 5 squared, or 25 pi. So to find the area of the ring, we would need to subtract these values and get 39 pi, right? Because to get this ring, it would be the entire circle minus the little circle. So now we get the shaded regions, 39 pi, the entire region, 64 pi. To find the probability we're in the ring, we would do 39 pi divided by 64 pi, which we could reduce down after we cancel out those pi's and get approximately 61%.